This is AP Calculus AB. We're looking at some calculator problems where we're trying to find connections between the original function, first derivative, and second derivative. Number one, the function f prime of x is cosine of natural log of x. It's the first derivative of a twice differentiable function. Every time I hear about twice differentiable, I think about a twice baked potato. I'm not sure why. On the interval from 0 to 10, so when we graph it, set your window from 0 to 10, find the x values where f has a relative maximum. Justify your answer. Well, let me tell you what we're looking for, and this is our justification. We want to know, where does f prime change from positive to negative? If we can figure out where it changes from positive to negative, that's going to tell us when f has relative maximums. Let's look at this graph. So here is this graph from 0 to 10. Now we got some funky things happening over in this location. We'll get to that in a moment. So we're looking for places when this graph, this is f prime, changes from being positive to negative. If we zoom in here, here's a location where it changes from positive to negative. Above 0.009, the graph f prime is above, so it's positive, and below it, it's negative. So there's one place. And it happens again when we come over here, this x-intercept. The graph is changing from being above to below f prime. So that's another place where it changes from positive to negative. Doesn't happen any place else from 0 to 10. So let's write those down. F prime changes from positive to negative at x equals 0.009. And it also happened at x equals 4.810. What conclusions can we draw from that? That's answering the question. Find the x values to where f has relative maximum. Therefore, f of x has relative maximums at these x values. Second question, what are the x values that f has relative minimums? Well, here we're looking for when f prime changes from negative to positive. So let's look at our graph and see when that happens. Changing from negative to positive definitely happens right here. And it happens no place else from 0 to 10, from negative to positive. So let's go back. Changes from negative to positive, that was at 208 thousandths. So the conclusion, f of x has relative minimum at this x value. Cool. C, Spanish for yes. On the interval from 0 to 10, find the x values where f of x has a point of inflection. Justify your answer. Well, let's justify it first. This is going to happen. Going to have a point of inflection on f anytime f prime has an extreme value. So let's find where the extrema are on the interval from 0 to 10. It says open interval, so here at 0, 1 doesn't really count. At least I think that's 0. Yeah, if I continue to zoom in, we can see there's a lot of weird stuff happening there. This might not have been the greatest graph in the world. Anyhow, extreme values from 0 to 10. Let's see, definitely got something going on here at 1. And I also had something down here clearly at 0.43. So f of x has extrema at x equals 0.043 and again at x equals 1. So our conclusion is f of x has points of inflection at these x values. As I'm writing that, I'm curious more about that graph. Let's look back at that again real quick to make sure we didn't miss any. So I want to zoom in super close here with these x values. So I'm going to go negative 0.01. And here I'm going to go positive 0.001. I need to zoom in more. Let's go 0.00001. Here, let's just go 0. All right, so I guess not too much is happening. I don't know what's happening up here. It's too hard to tell, quite frankly. So forget that I even mentioned it. Number 2, separate question. On the interval from 0 to 10, it's a different function. How many relative minimums will the function g prime have? Let's make sure that we're clear when this is going to happen. This is going to happen, relative minimums, when g prime is equal to 0. So let's check out our graph of this, which I think I have loaded. I need to change my window back to something reasonable. All right. So from 0 to 10, we're looking for, it says how many relative minimums does it have? So relative minimums happen, and I misspoke back here, not just when g prime is equal to 0. It's when g prime is changing from negative to positive. So specifically, when g prime changes from negative to positive. So let's look at this graph. Here, changing from positive to negative, that doesn't count. Here, changing from negative to positive, that counts. Here, changing from positive to negative, that doesn't count. On the interval from 0 to 10, this is only happening, I only got one time, changing from negative to positive, and that's at 2 pi. So we would say that is answer B. If it asks for a relative extrema, it would be 3. But the number of times where it changes from negative to positive is only once, so that answer is going to be 1. That concludes this portion of the notes. Actually, it concludes the whole chapter. Do your homework, study up.